Hello, um, here we go with the second part of our lesson on surface areas. Our driving question today is, how do I calculate the surface area of cuboids? So we're moving away from cubes and we're getting into cuboids, which are a little bit different. So we're going to start off with a reminder of what we've done in previous lessons. So I would like you just to have a quick think about these things. Make certain that you're comfortable doing these things. The first thing is drawing nets, because we're going to start off by drawing a net of a cuboid. The second thing, which we haven't come to yet, but we're going to be doing a great deal, is referring to these drawings as if we'd done them in plan, front and side elevation. So we're going to be using the words that we learned in another lesson quite often this lesson. If you can't remember everything about that, now would be a really good time to stop, go back and check those things, make certain you're ready to go before you start. Otherwise, you might get a bit confused. Finally, when you're actually doing this work a little bit later on, you're going to need a calculator. So when we stop to do this work, now this might be a really, really good time for you to go and get one. So first thing I'd like you to do, please, is just draw a net of that cuboid. Please include all the dimensions on it. I know it doesn't say so there, but I think it's really important that you do that. So put all the dimensions on it. Now stop the tape, answer that question, and then turn it back on when you're ready to continue. Okay, here's my cuboid that I've drawn. Here's one that I've prepared a little bit earlier, but I haven't written the dimensions on yet. I was going to do that. I'm going to do that now so that you can see exactly which bit goes where. If your net doesn't look exactly like that, but it still folds up the same way, that's absolutely fine. But this is the way I've drawn mine, and I'm going to label it that now. So the first thing that I know is my plan elevation, my look down on it. So the top surface is going to be 5 centimeters by 6 centimeters. I know that both of these are also 6 centimeters, but I need to mark how high they are, and that is going to be 3 centimeters. From here to here, which is the side elevation, that's going to be 3 centimeters. And finally, this one again, we're going to get back. This is going to be 6, the same as that one. So that's what you should have done. You could have put the entire length on here as well. But there's our measurements on the side of our cuboid net. Okay, once we've done that, we're going to move on. So if yours doesn't look exactly the same as that, then it really is quite different. You might need to stop and change it now. So pause for a few moments before going on to the next part. Right, so now we're going to get on to actually how we calculate the area, or the surface area of this cuboid. If you look at this diagram, I'd like you for a moment to think about the sides labelled A, B and C. If you think about the work we did on drawing plans and elevations, the top surface, A, is the plan view. Now obviously there is a top and a bottom, and they're going to be both identical. Similarly, B is the front view. Once again, there are two. You've got the front and the back, and they're going to be identical. And finally, we have C, which is the side elevation. And once again, there's a side. There are two sides. And both of those are going to be identical. So armed with that, let's look at how they've calculated the surface area. What they've done is they've found the area of A, which is 4 times 5, and multiplied it by 2. They've added that to the area of B, the front elevation, which again has been multiplied by 2, and they've added that to C, the side elevation, which again has been multiplied by 2. 2 times 20 is 40, 2 times 12 is 24, 2 times 15 is 30, and if you add those numbers together you get 94 square centimetres. I'm going to work my way through a similar question now, but I just want you to understand how we've done that. The one I'm going to do now is the one that you've just drawn the net on. So I'm going to leave this up, but I'm going to reopen my diagram, and now I'm going to run through that again. So here's my cuboid. I'm just going to move that over a little bit for now. Here's my cuboid. The top surface, or A, is this side here and this side here. There are two of them. The front elevation is going to be I'm going to do my own. The front elevation I'm going to call this side. So this side here is going to be B, and obviously the one behind it is B. So that's looking at it when I fold it up that way. The sides I'm going to see is B, and if I look at it from this way and I've folded it up, the sides I'm going to see are going to be C. So let's look at the surface area of this.
I don't know that one.
Sorry about that. That was my Alexa talking. So side A. So we're going to write down the surface area. Please watch this. I will give you a chance to write this down afterwards. So surface area. A is, there are two lots of A, so that's going to be 2 times 5 times 6. 2 times 5 is 10. 10 times 6 is 60. B is 2, because there are two B's, times 5 times 3. 2 times 5 is 10, times 3 is 30. And finally C, we've got 2, because there are two of them, times 6 times 3. Well, 2 times 6 is 12. 12 times 3 is 36. So those are the surface areas of each of the sides, and now I add them together. Nothing and nothing and 6 is 6. 6 and 3 is 9. Add 3 is 12. So altogether, my surface area is 126 square centimeters. I'll pause the tape now for a few moments. Go through that and write that down. Please make certain you understand where all of those dimensions came from and how I worked out the surface area of that shape. Okay, that's the one we've just done. So now it's time for you to have a go at each one of these. If you want to draw the net, that's absolutely fine. You can draw the net. But perhaps the easiest way of doing it is to look at each of the 3 different rectangles that make up that shape in turn and work out the surface area of each pair, just like I've just done in that example there. So use the way I did it to calculate your own. I'm going to stop the tape now. I'd like you to work out those 4 and then come back when you're finished and we'll go through the answers. Well, I expect this one took a little bit of time because I do know this is quite a long process, but that's fine. Providing that you get the right answer in the end, it doesn't really matter how long it takes, so long as you understand what you're doing. So, let's have a look at this. So for question 10A, I'm going to do it exactly the same each time. I'm going to rely on A, B, and C. A is my plan. So looking down on it from above, and if I look down on it from above, I'm going to have a rectangle, or 2 rectangles, because there's one on the top, one on the bottom. 2 times 5 times 4. That will be A. B, the front elevation. So there'll be a front and a back. That will be 2 times 5 times 4 again. And lastly, my side elevation. So two different sides. 2 times 4 times 4. If you've got A, B, or C in a different order, it doesn't really matter. It will still work out the same. But I'm going to try and do it that way each time to make things a little bit clearer for everybody. So 2 times 5 is 10. 10 times 4 is 40. 2 times 5 is 10. 10 times 4 is 40. 2 times 4 is 8. Times 4 is 32. So that's the area of 3 pairs of sides. If I add those up, I get 2. 4 and 4 is 8, and 3 is 11. So the surface area of that first cuboid is 112 square centimeters. 10B. Once again, 3 different pairs, A, B, and C. The plan, looking down on the top, there are 2 of them, top and bottom, 2 times, in this case, we're going to have 7 times 9. So 7 times 9 is 63. Oh, sorry, let me finish. Okay, I'm going to do that one now. 7 times 9 is 63. 7 9s is 63. Times 2 is 126. For my next one, my front elevation, I'm going to have 2, front and back, times 7 centimeters wide, times 2 centimeters high. 2 times 7 is 14, times 2 is 28. And then lastly, I'm going to have 2 sides. This is my side elevation, times 9 centimeters wide, times 2 centimeters high. 2 times 9 is 18. 2 times 18 is 36. So if I add those 3 together, 6 and 8 is 14, and 6 is 20. Put down a 0, carry the 2. 2, add 2 is 4, add 3 is 7, add 2 is 9. And that leaves the 1 by itself, so that gives us 190. I check my diagram again. It's still centimeters, so 190 square centimeters. C, 3 pairs of sides, A, B, and C. My plan, looking down on it from the top, 2 sides, top and bottom, 2 times 1 meter wide by 1 meter long. My front elevation, front and back, 2 times 1 meter wide by 6 meters high. And lastly, my side elevation, again, 2 sides, 2 times 1 meter wide by 6 meters high. 2 times 1 times 1 is 2. 2 times 1 times 6 is 12. 2 times 1 times 6 is also 12. Giving me a grand total of 26. I check, this time the diagram is in meters, so it's 26 square meters. Please make certain you've got that unit of measurement correct. If it's not, it could make a huge difference. So on to the last one, question D. Again, 3 pairs of sides, A, B, and C. Looking down on it, my plan is two sides, top and bottom, times 48 times 13. Told you I needed the calculator. The next question, the front elevation, I've said is 2 sides times 48 times 25. And lastly, my side elevation, 2 times 13 times 25. Working those out, 2 times 48 times 13 is 1,248. 2 times 48 times 25 is 2,400. And 2 times 13 times 25 is 650. This was the one you needed the calculator for. 8 and nothing is 8. 4 add nothing add 5 is 9. 2 add 4 is 6. Add 6 is 12. 1 add 2 is 3. And 1 I should have written down there is 4. 4,298. I look at the diagram. This is in millimeters, so my number is 4,298 square millimeters. I hope by using A, B, and C and plan, front elevation and side elevation, you understand where I've got all my measurements from. I'm going to keep on using this throughout this entire lesson. If you're unhappy with anything that you've done so far, stop now. Stop this tape, have another look, make certain you understand. I'll sort of give you a little bit of a gap and then we'll move on to our next question. Okay, so hope you're back. Problem solving. Let's have a look at this. A new building is a cuboid 65 metres long by 40 metres wide by 220 metres high. That is a really, really, really tall building. It will be covered in glass panels on all 4 sides, but not the roof. Work out the surface area of glass needed. The glass panels cost £128 per square metre. Work out the cost of the glass panels for this building. Show how to check your answer using an estimation. Okay, for this, what we've got here in this new building is we need glass panels on the sides, but not the roof. And obviously not on the ground either. So all we need are the 4 sides. The 4 sides from our definition that I've been using up to now are the front elevation and the side elevation. So we want to just work out the front elevation and the side elevation for these. Have a go at the question, and when you're doing it, pause the tape, have a go, and come back to me when you're finished. Okay, I'm going to start this one off with a bit of a diagram to show you what we're actually dealing with. So I'm going to very, very quickly draw a quick sketch of what we've got here. We've got a building that sort of looks a bit like that. I know there's no doors in it, it's not much of a building. I'm not that concerned about the area of the roof, because the roof has got roof materials on. But I do need to know about these 2 sides. So this is going to be my front elevation. This is going to be my side elevation. So I'm going to call this one B. I'm going to call this one C. Now, let's have a look at the information that we've got. A new building is 65 metres long, so from here to here is 65 metres, and 40 metres wide, so from here to here is 40 metres. It's also 220 metres high, so from here to here is 220 metres. So this is side B, this is side C. Sometimes doing a diagram, even if you're not told to, makes doing the work a little bit easier. I'm hoping that this diagram will help. So if I look at my standard form, I've got A, B, and C. I don't care about A, the top, the plans. I don't care about some. I've only just written it there just to show I haven't forgotten it. Side B, the front elevation is, there's 2 of them. There's the front and the back. They are 65 metres long and they are 220 metres high. And C, the side elevation, there are 2 of them, front and back, and they are 40 metres long by 220 metres high. So if I get my calculator out again and work those out, I get 28,600. There, 2 times 65 times 220 is 28,600, and 2 times 40 times 220 is 17,600. if I add those two numbers together, I get 46,200. And because that's in meter, because both of the dimensions were in meters, the area of the walls, the surface area of the walls of this building are 46,200 square meters. That's the answer to part A. That's how much glass we're going to need. 46,200 square meters, a lot of glass. The glass panels cost £128 per square meter. So for every square meter, I've got to spend £128. Work out the cost of the glass panels for this building. Well, the cost of the glass panels for this building are going to be 46,200 times 128. If I multiply that together, I get 5,913,600. And that is pounds. Nearly £6 million. Can't buy a footballer for that. Now, the question says, show how to check your answer using an estimation, an estimate. An estimate isn't a guess. What we do is we round these numbers to one significant figure, that is one number. So we can do this in our heads. Well, 46,200, if I round that to the nearest 10,000, is nearest, because that's the biggest number. This number here is 10,000s, so I'm going to round this number to 10,000s, and the nearest 10,000 to 46,000 is 50,000. The biggest number, or the biggest place value in this number, is hundreds, so I'm going to round this to the nearest 100, and the nearest 100 to 128 is 100. So now, to work that out, I've got to multiply this number by this number. Well, 5 times 1 is 5, and I've got 1, 2, 3, 4, 5, 6 zeros left, so I've got to write down. So an estimate for the price would be 5 million. The real price is more than that, quite a lot more than that, but it's in the same, as we call it, order of magnitude. It's not 50 million, it's not 500,000, so the number of zeros is correct. So that represents a pretty good estimate. It's close enough to give us a good idea of how much money we're going to be spending. We're not going to be spending 50 million, we're not going to be spending 500,000, we're going to be spending around about 5 million. That's how we do an estimate. Okay, once again, if you haven't got that in that form, I suspect you might need to look at your estimate. Make certain that you've changed it, and when you've done that, rejoin me and we'll carry on with the next question. Okay, here's another problem. Marius needs to cover the top and sides of this cake with icing. One packet of icing covers 900 square centimeters. How many packets of icing does he need? Okay, so before you start with this, make certain you understand exactly what side you're going to be dealing with here. Because if you don't get that right, everything is going to be a little bit tricky. So pause the video now, work your way through this question, and come back to me when you're ready for the answer. So for this question, going back to our ABC, plan, front, side. In this case, when we're looking down on the cake, so our plan view How many sides are we actually? Are we going to bother icing the bottom of the cake? No, we're not. So we only need one of A. So A, the planned surface this time, is going to be 40 times 40. B, the front elevation, because we're doing all the way around the cake, we need the front and the back. We need 2 times 40 times 40 wide by 8 centimeters high. And lastly, C, the side elevation. Once again, we're going to need both sides iced, so we're going to need 2 times 40 times 8 centimeters high. These are our dimensions. So 4 times 4 is 60. I've missed out 16. I've missed out 2 zeros, so I've got to add those on to give me 1,600. 2 times 40 is 80. 8 times 80 is, well, 8 times 8 is 64, and I need to add a naught, so that will be 640. And this is exactly the same, so that's another 640. So overall, we have 2,880. I haven't put a unit on this yet, but it is 2,880 square centimeters. In fact, we will. Now, how many bags of icing do we have to buy? Well, to find out, I have to take my 2,880 square centimeters and divide it by 900 square centimeters. That gets rid of the square centimeters, and we get an answer that is 3.2 bags. Now, can I buy 3.2 bags of icing? No, I can't. Is it enough to buy 3 bags of icing? No, it is not. That will not ice the cake. There will be a bit missing. So, I must buy 4 bags. Okay? Does that make sense? Because obviously, if 3 bags isn't enough, he's got to buy 4 bags. Even though it's far too much, he's going to have to do something else with the rest of his icing. So that's the answers we were looking for. If you didn't quite finish this question off and you stopped at 2,880, okay, you've done your bit, but remember you've got to answer what the question says, and I did tell you that you needed to do that. So please make certain that you've got that done correctly and written down properly, and then we're going to move on to the next one. Okay, without calculating, estimate which of these cuboids has a large surface area. Give a reason for your estimate. Check your answers by calculating the actual surface area of each cuboid. This one is totally up to you. I'm not going to write down a reason why for the sizes. That's going to be up for you. You make your own estimate, your own appraisal, rather than guess. It's not a guess. You've got to have a really good reason. It's not good enough just to write down, I think it's bigger. Have a think. Try and think why one should be bigger than the other one. And when you've done that, work them out properly. And when you've done that, put the video back on and check with me for the answers. So, cuboid A has three different pairs of sides, A, B, C. The plan on A is going to be 2 lots of 5 centimeters times 5 centimeters. The front elevation is going to be two lots, front and back, of 5 centimeters by 2 centimeters high, and the side elevation is going to be two sides of 5 centimeters by 2 centimeters. So 2 times 5 is 10 times 5 is 50. 2 times 5 is 10 times 2 is 20. 2 times 5 is 10 times 2 is 20, for a total of 90 square centimeters. B, plan front side, top and bottom again. So 2 times 5 centimeters times 4 centimeters. I shouldn't have written centimeters for now, so we're going to ignore that. 2 times 5 is 10 times 4 is 40. The front elevation, 2, because front and back, times 4 times 3. And the side elevation, 2, both sides, times 5 times 3. So 2 times 4 is 8, times 3 is 24. And 2 times 5 is 10, times 3 is 30. So if we add those together, we get a 4 add 2 is 6, add 3 is 9. 94 square centimeters. So the one with the largest surface area is shape B. Have a look back at your reason and try and see if you can, if you didn't get that the way you thought it was going to be, have a little think, see if you can come up with what actually happened. When you're ready, pause the tape. When you're ready, restart it, and we'll get on with our next question. An open cardboard box has length 32 centimeters, width 12.5 centimeters, and height 16.5 centimeters. Work out the area of cardboard needed to make the open box. So, we've looked at, in previous lessons, we've looked at nets of open boxes before, so we know the shape we've got. In some ways, this is very, very similar to the cake, only it's upside down. So we've got the same sort of thing as the cake happening again, but this time it's upside down. See if you can see what difference that makes. So when you're ready, turn the video off or pause it. Have a go at working out the correct answer. So back to our normal method. A, B, C. In this case, we've only got one A. All we've got is the bottom of the box. We haven't got a top. So the area of the bottom of the box is going to be 32 times 12.5. Just 1 because we haven't got a top. The front elevation is going to be 2 because there's a front and a back, times 32 times 16.5. And the side elevation C, 2 sides, 2 times 12.5 times 16.5. And 32 times 12.5 400. 2 times 32 times 16.5 is 1056. And 2 times 12.5 times 16.5 is 412.5. Adding all of those together, I get 1868.5. And once again, we check our unit. Everything has been in centimeters, so my answer must be in square centimeters. Okay, if that's not what you've got, stop the tape, have a look at it, come back when you're ready to carry on. Okay, the challenge question, we're nearly there. Diagram shows a wooden shelf in the shape of a cuboid, so it's a plank. All its faces need to be painted with wood stain. 100 milliliters of wood stain covers an area of 4,000 square centimeters. How many identical shells can be stained using one 500 milliliter tin of wood stain? Okay, the first thing that we have to do in this case is work out the surface area of the plank. Once we've done that, everything else we will be okay with. So pause the tape, answer the question, come back when you're ready to have your answer checked. Okay, so hopefully how I'm going to start this should be quite familiar now. A, B, C. The plan, in this case it says all the faces, so we're going to paint everything. So the plan of my shape, looking down on it, I'm going to have a top and a bottom, and that's going to be 80 centimeters by 30 centimeters. My front elevation, front and back, is going to be 2 times 80 times 5 centimeters high, and my side elevation, two sides, 2 times 30 times 5 centimeters high. Multiplying those together, 2 times 80 times 30 is 4,800. 2 times 80 times 5 is, sorry, missed a 0, 800. And 2 times 30 times 5 is 300. If I add all those together, I get 5,900, check my unit, square centimeters. So 100 milliliters of wood stain covers an area of 4,000 square centimeters. How much in that case is 500 milliliters going to cover? Well, there's 5 times as much paint, so it will cover 5 times the area. So the first thing I've got to do is a quick calculation of 5 times 4,000. 5 times 4,000 is 20,000. So altogether, that half litre of paint will cover 20,000 square centimetres. Sorry, the 500 millilitres of paint will cover 20,000 square centimetres. To find out how many shells that will do, we've got to do 20,000 divided by 5,900. If I do that on my calculator, I get an answer that I can round to 3.39. 3.39 shelves. Now, in some ways, this question gets back to what we were doing with the icing question. How many, in this case, it works slightly differently. In this case, is 0.39 of a shelf a whole shelf? No. So I haven't got enough to do the fourth shelf with that half litre. So 500 millilitres of wood stain will cover 3 shelves. Okay, because it will not cover the fourth. We're going to need more paint to cover the fourth. Okay, if that wasn't your answer, have a quick look through my work. Well, I'll pause the tape, have a quick look through my work, and then join us for the last question. Okay, once again, you don't get any answers for this. This is your chance just to think about how we've been doing and what you've been doing for the last few minutes, or for the last 2 lessons. You've been shown 2 different ways of calculating the surface area of cubes and cuboids. Method 1, which we did first, was to draw it, work out the area of each of the sides, and then add them together after withdrawing your net, which we did both for cubes and for cuboids. And method 2 was to say, right, okay, I know what the shape looks like. I know it's either 6 identical sides for a cuboid or 3 pairs, or however it worked out. 6 identical sides for cubes, 3 pairs sometimes of sides for cuboids. I know that. I get it in my head. I can work it out. So have a think to yourself. What worked well? Which method did you prefer? Did you want to draw them all to understand what you were doing? Or did you think once you sort of got the hang of it, it was faster and easier to do it just visualizing and building the shape in your head? There's no right answer. There's no wrong answer. The important thing is you decide how you're going to be able to do this from now on, because obviously this is something you're going to be doing over and over again, and it's best that you don't have to start again from the beginning. So put a bit of thought into it now and make certain that you understand exactly what you're doing the next time you're faced with one of these questions. So that's the lesson over. I hope you learned something, and I'll talk to you again soon. Goodbye.